Hi there, this is Mr. Nash, and this is going to be lesson 4 of Physics with Nash. So we're going to continue talking about some kinematics here. So I just want to put this in as a reminder. Uh, what is key? So just like a lot of classes that involve math and any kind of word problems, you're going to want to do practice problems. In these videos, we're just reviewing the concepts, and it's all fine if you remember the concepts, but the whole thing is that you're going to need to apply them to the problems. And sometimes it seems like easy, like, I bet I could do that. But until you sit down and actually do it, you're not going to really know how that's going to pan out. And you may have an exam that's timed, so you want to be able to do these things relatively quickly, but also um, be careful to not make certain mistakes. Like common mistakes that you can do, probably one of the most common is you didn't do a negative when you should have, or vice versa, like mixing up if it should be negative or positive. That's a common one. So there can be things like that that you would only be able to miss unless you did, or you would only be able to avoid those mistakes by doing practice problems. But don't worry, because I definitely will make a video soon, um, going through problems applying to all these videos that we've done so far. So obviously these um, concepts are just going to be explained in brief because it's supposed to be review, but also because we'll apply it and it'll make more sense when we see actual problems. But we can have inclined plane motion. So all that means is something like this, where there's an incline, and that incline can be described by a certain angle. Um, and we are going to also, just like in free fall, have acceleration due to free fall, a free fall, involved with this calculation. Now, if you took AP Physics 1, which I've done videos on, remember that's described as g, that lowercase g, which is 9.8, roughly 9.8 meters per second squared. But, we can label that as negative, since it's in the downward direction. So that's going to be important to do. Um, and if you want to find the acceleration happening parallel to the incline, if you can see by this picture, we can break up the vectors. So just the acceleration to free fall, okay, you can see that's obviously directly down. If we do like free body diagrams, that's what you do. If you remember, or if you've never done this, then you might not know what that is, but we'll do that later on. But we always have that force down. The force or perpendicular is not going to be something that we need to care about right now. What we care about is this acceleration, which we can really say is the acceleration in the x direction. We'll talk more about how you can have a tilted coordinate system, but if you want to make this the x direction, this is that also just parallel to the incline. And to find that, you just say, okay, we'll do that 9.8, multiply that by sine of the angle. So it's basically saying this right here is inclinating the acceleration, if you want to say, just by multiplying it by sine of the angle. So it's that 9.8 times that. Um, but be careful of if it would be negative or positive depending on the context of the problem. So here's some misconceptions. Acceleration is not going to be the zero at the top of an incline if it is sliding up. Why? Well, because it doesn't just magically go away. We're going to still have an effect that we will still have that 9.8 in effect at all times. Gravity is always in effect. Acceleration is also not going to be negative when slowing down. Remember, that's not what that means. Slowing down doesn't mean negative acceleration. It matters about, is it doing the same thing as the velocity or not? Doing opposite thing, negative. Doing the same thing as velocity, positive. All right. Now, how can we break a vector apart into directions? Um, what you can do, now that depends on the angle, In a situation like this where the angle is against an x-axis, that's key. If it's against an x-axis, then sine goes with y, cosine goes with x. That's if this angle is against an x-axis, if you can see. So that's all you have to do. You just take the full thing, and I say thing, but whatever it happens to be, whatever, and we say vector, but we could really just be talking about velocity or acceleration, or, and yeah, that's really only what we're going to talk about for now. And if you want to get the component of it for the y, it's going to be, you do whatever it is, see, times sine of the angle, or for x, whatever it is, times cosine of the angle. Now, if it's against the y-axis, see, that's different now. Um, Now it's going to be, okay, now cosine's with y and sine is with x. So don't always think, okay, always sine is with y, always cosine is with x. It depends on what that angle is against. If it's against the x-axis, that's going to be the case. If it's against the y, that's going to be the case. I will say, though, this is going to be more often what it is, and with the incline, because obviously an incline's not like this. That's horrible. That's not. Well, I mean, technically, if that's the angle you were thinking of from the incline, but usually we use this one. So, anyways, just be careful of that. And then you can rearrange, you know, to find other things too. So don't really have to think about those things right now. But now let's talk about unit vectors. This is not something that we would have seen in AP Physics. And I keep saying that, by the way. Like, if you never took that, then that's just disregard that. But I'm just saying that because I've made videos on that. So these are the vectors. If you can see that they're going to have a magnitude of 1 and no units. And why it's called a unit vector is not because it has units, obviously, because it says no units. It's because if they all have a magnitude of 1, that's going to be like how there's a radius of 1 for a unit circle. That don't worry, that doesn't mean you have to like memorize unit circle, but that's just why it's called that. Um, and you can see the two representations. If we're talking about a unit vector in the x direction, it's labeled as I hat and then j hat for the y direction. So that's always how it is. Um, these, the purpose of these is it's going to help us establish the positive direction, and it will make more sense when you look at examples. Um, but these are not involved in kinematic equations. All right, let's see here.